Okay, so these equations that we just discussed previously. So x is a sine omega nt plus b cos omega nt, and we can also represent this by c sine omega nt plus pi. And we showed that this a is equal to c cos pi and b is equal to c sine pi. Now, obviously, this is hard to graphically represent this equation, and therefore we express this equation in this form here. So because it is just only one sine function, so we can represent this graphically. And as you can see in this figure here, so this is the plot for this figure here. Now, in this case, you can see again that this on the x-axis we have omega nt, and in the y-axis we have x. So if we just change time here, you will be able to get x, and then you can plot at x here, and then you will see this sine curve here. Now the thing is, if you look at this the sine omega nt, and in addition to this you have pi here. This pi is what we call is the phase angle, and from here to here you have this is our sine c sine pi, because if time is 0, so then the x will become c sine pi, and the maximum amplitude is c here. And if this distance from here to here is pi, so if you put in this equation, if you put omega nt equal to minus pi, so this will become equal to 0, and this pi here. And again the time period is again from here to here, which is again 2 pi, or one cycle, and this is again you can say is omega n tau. Okay, so the maximum displacement of the block from its equilibrium position, that is c, is defined is the amplitude of the vibration. So this c is the amplitude, and the angle pi, which is this angle here, and we can also show this in figure here. That is what we call is the phase angle, since it represents the amount by which the curve is displaced from the origin when t equals 0. So if uh, you can see that this pi angle displays the sine curve from its 0 position to this position here, and therefore we call it a phase angle. Now this c and pi is obviously can be relate to a and b, because we already know a and b, so you can calculate c and pi from a and b, uh, which you can say that if you take these two equation a and b, and you just square these two equation and add these together, so what you will get, c square equal to a square plus b square, because cos square pi plus sine square pi is equal to 1. So you will get this equation here, and from here then you can calculate c, which will be a square plus b square under the root. So if you know a and b, you can calculate c. And similarly, if you divide sine by cos, so what you will get tangent pi equal to b by a. So from here you can calculate pi angle, which is just b by a tangent inverse. You can calculate this angle from this equation here. And now the sine curve complete one cycle in time tau, t equal to tau. So that is tau is again the time period here of this plot. And obviously for this case, we can say that omega nt is equal to 2 pi. And from here then you can calculate time period. So time period will become equal to 2 pi divided by omega n. So from here you can calculate time period, which is 2 pi divided by omega n, and we already know the value of the omega n, which is so this time period can also be written as, so this tau will become equal to 2 pi, and omega n is we know that it's k divided by m under the root. Then time period will become equal to 2 pi and m divided by k under the root. So this is the value of the time period here. And in addition to this, we also then can define this frequency. So this frequency, which is f here, is defined is the number of cycle completed per unit time, and which is the reciprocal of time period. And because we know that f is equal to 1 over tau, and now we know the value of the tau here, so then f will become equal to 1 over 2 pi and k divided by m under the root. Or in other word, because we know that omega n is equal to k divided by m, and because this is in radian per second, so you want to convert this into cycle per second, so you will just divide this by, so if you, so f n, which is the natural frequency, is equal to omega n divided by 2 pi, and this will be cycles per second. So if you just then write the value that fn become equal to 1 over 2 pi, and then omega n is k divided by m. So this is the this is how you can get the fn. So omega n and fn are both natural frequencies, but omega n is in radian per second and fn is in cycle per second. Now the frequency is expressed in cycle per second. So this ratio of unit is called a hertz, where 1 hertz is equal to 1 cycle per second, or 2 pi radian per second. And now when a body of a system of connected body is given an initial displacement from its equilibrium position and released, it will vibrate with its natural frequency. Okay, so this is the end of today's lecture. So just to summarize what we did in today's lecture, we discussed about the type of vibration, that is a free vibration and forced vibration. And we also discussed about damped vibration and undamped vibration. We also discussed about the degrees of freedom of a system. And in this course, we will only be discussing single degrees of freedom system. And then we discuss about periodic motion and simple harmonic motion. And then we represent the x, which was a sine omega t. And the velocity and acceleration can be obtained by just differentiating this equation with respect to time. And these are the plots for the simple harmonic motion for the velocity, displacement, and acceleration. And we also show that the velocity is at angle 90 to the displacement, as you can see in this equation here. And similarly, the acceleration is at 180 degree to the displacement here, which you can see here. And now for the equation of a motion for the undamped free vibration. So if you consider this mass which is vibrating on a horizontal surface, or it can vibrate in a vertical direction, so the equation of motion can be represented by this equation here. So minus kx equal to mx double dot, and then this equation become x double dot plus omega n square x equals 0, where this omega n is the natural frequency, and which is the k divided by m under the root. And now if you want to see this equation, it's a homogeneous linear second order differential equation. So the solution of this system is a sine omega nt plus b cos omega nt. And then we can calculate a and b from the initial condition. So the initial condition is that that at t is equal to 0, x is equal to x1, and v is equal to v1. So these are our initial condition. So from this initial condition, we can calculate a and b. So a become equal to v1 divided by omega n square, and b become equal to x1. So then this equation become equal to this equation here. And then because this equation is a little bit complicated, because it consists of sine angle and cosine angle. So to just replace this by a simple equation, we will replace a and b by this this term here, so c and pi. and then we can write this equation in this form here. And this equation is simple. You can draw it in a plot, which we did this equation here, and we show that this c is the amplitude of this x, so the maximum displacement here, and then pi is the phase angle which shift the sine curve to the left hand side. And from here we can calculate the time period, which is 2 pi divided by omega n. And from here we can calculate t, which is 2 pi k divided by m divided by k under root. And again we can calculate f, which is obviously 1 over tau.